Okay, so when you're modeling data using technology, we are going to be using some of our regression functions, and today we're also going to learn about exponential regression. So it says the table shows the tuition rates for the University of Texas in Austin in the early 2000s, and then we are changing this. So this should have said find an exponential model of the data. Then we're going to use the model to predict when the tuition at UT Austin will be $6,000. So if it tells you to find an exponential model, that's what you're going to do. Sometimes it might tell you to determine between two models, and we'll go over that in the next one. So to find the exponential model, you are going to use exponential regression. Okay, so in order to do that, in our graphing calculator, we're going to go to Stat, and that's going to pull up an Edit button. So you're going to press Enter, and then some of you might have other data in there. If so, you can clear that out. Some of the data I'm going to use again. So if it's the year from the 99 to 2000, we're going to plug this in as, do you guys remember?
One.
Nope. Zero. So 0, 1, 2, 3, 4. So then these are the years since like 99, 2000, that school year. Okay, so I already had 0, 1, 2, 3, so I can just delete the 5, and I can delete the 6, okay, to get my 0, 1, 2, 3, 4. And then this is the tuition, so it's 3128, 3585, 3776, 3950, and 4188. Make sure that these do line up so that you don't get a dimension error. Okay, and then remember, if you need to clear out a full one, you press clear Enter.
How do I clear out like one thing?
Just highlight it and press delete. Okay, and then if you go to Stat, so I'll put so you press Stat, you go to Edit, okay, L1 is always the input, so in this case it's the year. L2 is the output, in this case that's the tuition. So this is your L1, this is L2. Okay, and then from there, you're going to go to Stat, and then over to Calc. So when you go to Stat and over to Calc, because you're doing the exponential model, we're going to go all the way down here to exponential regression. So it's EXP reg. Okay, it stands for exponential regression. Okay, and then when you press Enter, it'll ask you what your X and your Y are. It's the L1 and L2, and then you're going to calculate. So it even tells you what the model is up here, even though we already know our exponential model is Y equals A times B to the X. And then they give you the values for A and B. So again, we're just going to round that to the nearest 1,000. So that's how many places after the decimal? 3. So 3235.644. Okay, and then 1.07, and that will stay a 0 to the power of x. Make sure that is written as an exponent. It can't be next to it. If it was next to it and not an exponent, what type of function would it be? Linear, be a line. Okay, so this is going to be your function. Okay, and then it says to use the model to predict when the tuition will be 6,000. So the tuition is your output or your Y value. So if you're trying to find the output, that's when you're going to put that in your y equals, and you're going to find the intersection. Okay, so when you're finding when the tuition will be 6,000, we're using that model. Okay, we're going to put this in y1, and then 2, we're going to graph model, and y equals 6,000, and then we're going to find the intersection. And so we can plug in this, the 1.0. Yeah, we can use the rounded one. These aren't too bad. It's not like the quartic ones that we did. Remember when we had to do the quartic and the cubic? Yeah. Okay, and then so for y2, if I'm gonna do 6,000 here, then when I am looking at my window, I gotta make sure that I'm making this bigger. Okay, so yeah, I can go from 0 to 20 for the axis and see where it is and see if I need to adjust. But my y max has got to be more than 6,000. Usually I double it so that the 6,000 is in the middle because it's easier for you to find an intersection. But if you make this 12,000, then your scale should be like 1,000. That way you don't have a whole bunch of tick marks in there. And then when you graph, you should easily see the intersection. Oh, the zoom fit? Yeah, that does work. That does work sometimes. I know some people have had trouble with it, but yep, you can do the zoom fit as well.
That definitely did not work. It worked for me.
It didn't work on yours. And then we're going to go to second calc, and then intersect, and then you try to get it right where they meet, and then first curve, second curve, your guess. Okay, and so you have x is 1.297. So in this case, your x is about 9. So it's asking you, when will the tuition be 6,000? So let's look at the correlation here. For year 0, it was 9900, 2000 to 2001, 01 to 02. So in 9, what would this be? Yes, 08, 09, right? See how 4 is 4, 3 is 3, 2 is 2, 1 is 1 for the second one? So that means 9 would be 08 to 09. So when would the tuition be 6,000? In the 2008-2009 school year. Was that when some of you were born? Before that?
You were born in 2000.
He was. See? So make sure that if they're asking you like when the year is, that you have that year written down. Okay, and then for example 3, it says the operations manager of an amusement park analyzed data showing the number of visitors each year since 2014. And we have that in the chart as well. Okay, now notice that here it says the visitors are in thousands. So there's not 12.3 visitors, really, there'd be 12,300, okay? So you're going to use the data to determine a best fit model. So when you have to use the data to determine the best fit model, okay, what you're going to do is identify the coefficient of determination for each regression. Do you guys remember what that is? The tech people are going to come visit me for my job camera props. Okay, and then do you guys remember what the coefficient of determination is? your r squared value. Okay, so if you're using the data to determine the model, if they don't tell you your options, like which one to use, then all you have to find is linreg, quadreg, and exponential reg. Okay, you don't have to do the cubic and quartic. Now, sometimes they will say, oh, is it linear or exponential? If they just are asking you to choose between those two, just find those two. Okay? If they're asking you if it's quadratic or exponential, just find those two. If they don't give you anything specific, then find linear, quadratic, and exponential. Okay, so linreg is linear, so we're going to do that first. So we're going to go ahead, we're going to go back to stat, we're going to edit our list, and then see how you have 0, 1, 2, 3, 4. So we can just go here and do 5 and 6. And then instead of clearing it out, I'm just going to enter this over it. So 12.3, 12.4. So do this with me, please. 12.5, 12.6, 12.8, 13.1, 13.4. Again, make sure that those line up and that you didn't accidentally miss one. And then we're going to go to stat, arrow over to calc, and then linreg is number 4, and then you're going to calculate. Okay, so your r squared, sometimes you might have to go more than the thousands place, so just keep that in mind. I'm going to do 9, 3, 5, 6.
How do you turn the linreg back up?
Oh, if your linreg is off, just go to your mode, and then stat diagnostics, just make sure that on is highlighted. So if your off is highlighted, just arrow it over to on, press enter, and you should be good. So it's stat diagnostics. Yep. Okay, and then this was our r squared, so now we're going to do the quadratic. So quadratic is 5, right underneath here, okay? So your r squared is 0.9960. And really, like I said, you can go to the thousands place. It's just sometimes you might have to look a little further because they may be very close together. And now we're going to go to 0, which is the exponential regression. And again, you're looking at r squared, because see how you have r squared and r there? Okay, you're going to be looking at the r squared. Okay, now, to determine which one is the best fit, you're looking for the one that is what? Yeah, good. So which one's closest to 1? Yes. Okay, so the r squared is closest to 1. Therefore, quadratic is the best fit. Okay, so the best fit model is going to be from the regression. So we are going to write that. Okay, so we're going to go to stat, over to calc, and back to quadratic so we can write down our model. Okay, so if it is quadratic, it's going to look exactly like our quadratic formula. Okay, so y equals ax squared plus bx plus c. Okay, this is our quadratic equation, not formula. Okay, and then we're going to plug in the a, the b, and the c, and we're just going to round to the nearest thousandth. So y equals 0.026 x squared plus your b value would be 0.021, that's the rounded value, plus 12.32, and then that 3 gets rounded up to a 4, This is your quadratic model. This is your model of best fit. Okay, your model does have to have y equals or f of x equals in there. Okay, any questions about part A? So finding the model, determining the best fit, how to determine which one is the one you want. Okay, then let's move to part B. So it says, in what year should the operations manager expect the park to have more than 15,000 visitors? This is actually a little trickier than it seems. Do you guys have some ideas on how we're going to solve it? Uh-huh. Okay, yep, so we have to put something into y equals. What should we put into y equals? Why 15 and not 15,000? Yes. So look at your model. Okay? Do you see how this says it's visitors in thousands? Okay? And at the beginning we talked about this isn't 12.3, this is 12,300. So with this model, you are going to have to write 15,000 is 15. Okay? So just be careful of things like that. And if you're doing the in what year, you do have to make sure that you are using the intersect feature. Okay, so we're going to put our quadratic model into our y equals. And we're also going to put in 15. And then again, think about what you want your scale to be. Okay, so on my window, I can go in here. So I adjusted it to 12,000, so I'm not going to want it to be that far up. So if it's 15, maybe I would go to 20 or 25. Could go by ones or twos. Okay, and then we would find the intersection by going second calc. And then this one I do have to move over a little. Sometimes they do a really nice job of just putting it right close to the intersection for you. And it says in what year. So your x value is 9.75. So it says in what year should it be. So if it's asking you for the year, you can round. This would be approximately 10 years. And remember, it's years since 2014. So if it's approximately 10 years since 2014, what year is it? Yep. Because what would still be in the ninth year?
It's like 9.7 is like your 9 and
Yeah.
number into the year. So
Right. Yep. If you wanted to say that and leave it as the 9.75, that'd be fine. I'd be impressed if you told me what month it's in. Okay. And then yeah. So just look and see what it says. Like if you're rounding to the nearest year, right? Your model is an approximation, so you can just round up on that. Yeah. And then for part C, it says how many visitors should the operations manager expect to have in the park in 2030? So how are we going to find this one? So do what? Nope. So this one's different. So this was our output, right? Yeah. Me?
Second trace, and then that's 16.
I don't want you to use the trace button. You could use something else though. Okay, yeah, you could use the value button. Yep. What else could you do? Yeah, you could use your table. So if you already have this in your Y, I would use your table, but you could also do the value. So just make sure that you're plugging in the right value for X. If it's in 2030, what am I plugging in for X? Yep, so the year since 2014 would be X is 16. Several different ways to find that. Well, you could even plug it in to your model if you wanted. Well, that's really what your table is doing. So if you just go to second table, you can scroll down to 16, and then I always highlight it in case there is something extra. So Y is 19.316. So remember, how many visitors is this?
9,000.
Yep. So in 2030, there are about 19,316 visitors. Okay, do not just say that there's about 19 visitors. Okay, because that's not accurate. You have to either write out the 1,000 like I did, or you would have to say 1,000 in words. Okay, something to indicate the 1,000. Okay? Sorry that that's bumpy, but that's my document camera situation.